All right, so I'm going to go over the questions that came from the starter, the bell ringer today in class, because they cover both the graphing systems of equations as well as the substitution to solve for systems of equations. So the first problem that we did today in class was y equals 1/3 x minus 2 and y equals negative 1/3 x plus 4. And we are asked to graph the following systems of equations and state their solution. So I'm going to graph this one right here in red. Now remember, when we graph using, it's already in y equals mx plus b form. So in this equation, my b value, or my y-intercept, is a negative 2, and my m, which is my slope, is 1/3. So I'm going to start at negative 2, and I'm going to move from that point up 1 to the right 3, up 1 to the right 3, up 1 to the right 3. Now, I gave you guys graph paper on there. I'm just sketching this out, so mine is not going to be as pretty as yours should have been. Then I'm going to put this one in blue. So here, again, I've got my y equals mx plus b form. So my b value equals 4, and my m equals negative 1/3. So again, my b is my y-intercept, so that's my starting point. So I'm going to go up to 4 on my y-intercept. Then my slope is a negative 1/3. So I'm going to go from that point down 1 to the right 3, down 1 to the right 3, down 1 to the right 3. Now, I'm looking for that intersection point because that is the solution to my systems of equations. So it's great that I found it. So for this problem, the solution to my systems of equations while graphing is 9, 1. Now, if I did the same set of equations algebraically, I would get that same answer, okay? All right, on number 2, again, we're graphing. So our end result is we're going to have a graph. And I gave you the equation x minus y equals 2 and 3y plus 2x equals 9. Well, both of these, I have to do some work before I have it in that slope-intercept form. So I'm going to take this, and I am simply going to, if I just added, well, here's how I'm going to do this problem. I have x minus y is equal to 2. If I know what you guys are going to do. Let's subtract x from both sides, which then gives me a negative y is equal to 2 minus x, or negative x plus 2. And then we're going to divide everything by a negative 1. And again, what I do to one, I've got to do to all of them. So my end result would be y is equal to a negative 2 plus x, or x minus 2. This second one, I also have to do some work too. Now, I want to solve for y. So my first step is I'm going to subtract 2x from both sides. And again, this is not new. This is stuff we've been working on as well as you worked on in middle school. So then I have negative 2x plus 9, okay? And then I'm going to divide everything by 3. Everything by 3. Now, I could have done these two steps in the opposite order, still would have got the same result. I just would have had a different looking problem, okay? So there are my two equations I'm going to graph. So now I need to make my graph, and I'm going to make my graph, and I'm going to make it like this. And so I know I'm going to need that negative 2. 1, 2, 3. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 1, 2, 3, 4, 5. And of course, remembering this is a negative, this is a 1, this is a 2, this is a 3, this is a 4, a 1, a 2, 3, negative 1, negative 2, negative 1, negative 2, negative 3, etc. Just to give you an idea of how my graph is going to look. So I'm going to go ahead and graph, I'll graph this first equation in red. And so I need to start up at 3. And then I need to go down 2 to the right 3. And I may go twice just to see the formation of my line. Wow, I did not connect those really well at all. And this line is going to be my blue line. So here I'm going to start at negative 2. And my slope is 1. So I go up 1 over 1, up 1 over 1. And I'm looking for the point where they cross. Up 1 over 1. Oh, there we go. There is the point they cross. So now the solution to this systems of equations is right at that point where they cross, which would be 3, 1. All right, so now we change the rules on you. We said, okay, now use substitution to solve the systems of equations below. So now we're not going to graph these. We could graph them and would get the same answer, but sometimes graphing, A, it takes a lot longer. B, if we get answers that are decimals or fractions, graphing is not our most efficient tool. So we're going to use the tool of substitution. Now, one reason why this is perfectly set up for substitution is because of that right there. That is already solved for a variable. So I am going to use the top equation and plug in that bottom information. As I've said in class, if this x is equal to 1 minus 4y, I can now substitute in that 1 minus 4y in for that x above. So when I do so, I'm going to have 2 parentheses 1 minus 4y plus 7y is equal to 3. Notice nothing changed from that equation other than I am now substituting that x for this information right now, because this now eliminates one of the variables, so I can actually continue and solve this. Now, you guys are great at this. We know to distribute, and you guys have really done a great job with that. So that's where we get our 2 minus 8y plus 7y is equal to 3. So again, I'm just continuing to solve the problem. Well, now I have to combine like terms. So for some of you, this is where maybe a mistake comes up. So minus 8y plus 7y is a minus y. So make sure you pay attention to that. This right here, minus 8y plus 7y is not 15. It's indeed minus 1 or a minus y. So now it's kind of old school for you guys. We subtract 2 from both sides. We get negative y is equal to 1. We don't like a negative y, so we divide both sides by a negative 1. And we end up with y is equal to negative 1. Now again, like we've talked in class, we're not done. We are only halfway done with this problem. We need to go back and return and figure out what the x is, because remember, we're going for a point, an ordered pair. So I'm going to plug it back in up here. I know that x is equal to 1 minus 4y, so I know that x is equal to 1 minus 4 times negative 1, because that's what my y is in this particular problem at this point, their solution. So I have 1 plus 4, so thus x equals 5. So for my final answer, how I would see it would be 5 comma negative 1. That would be the final answer. All right, so here's the next one, number 4. Number 4 gave me the two equations, and again, we're using substitution. 4x plus 5y equals 11, and y equals 3x minus 13. So again, this is great. I love this because this is already, someone did the work for me. I don't have to do the work. So, like we talked about, if my y is equal to 3x minus 13, I can replace and substitute that 3x minus 13 in for my y. So when I do this, my new equation is going to be 4x plus 5 parentheses 3x minus 13, because that is my y value, is equal to 11. Now again, you guys have been rocking it out at this. You know to distribute this. So you ended up with 4x plus 15x minus 65 is equal to 11. You've been doing great. So now we're combining like terms, and this is a pretty combining like terms because these are pretty easy here. 19x minus 65 is equal to 11. Let's go ahead and add 65 to both sides. And you get 19x is equal to 76. Divide both sides by 19. And you end up with x is equal to 4. Again, we're not done. We have to go back up to the original part of this equation because now we need to solve for y. So we go back up here and we say, well, we know that y is equal to 3x minus 13. So that means y is equal to 3 times 4 minus 13. So y is equal to 12 minus 13. So thus y is equal to negative 1. So again, for a final answer, I need to write it in ordered pair form, x comma y. So I would write it as 4 comma negative 1 for my final answer. All right, so we're being asked to solve algebraically by using substitution to solve the systems of equations. Now, this looks a little different than the last two that we did because now I don't have an equation that's already set equal to just one variable. However, when I look at these two equations, my key thing that I'm going to look for is which one has a variable that has a coefficient of 1. So, of course, we know if there's not a number written there, the coefficient is 1, because coefficient is a big fancy word to say the number to the left of the variable. So I can take my pick. I can either solve the top equation for C, or I can solve the bottom equation for D. It doesn't matter. This is where I know some of you don't like it, because now you get to choose, and so the variety comes. I am going to personally choose to solve this top equation for C, because again, I like positive world, and when doing so, I can add 5D to both sides, because I'm solving for C, and I get C is equal to 2 plus 5D. So I took that from the top equation, all right? Now, that means I'm going to plug it in, that new value, into the bottom of equation. So again, here I'm saying, hey, this C is now 2 plus 5D, because it was up there. I just rearranged the letters and the numbers. That's all I did. So I'm going to take this equation, this 2C plus D equals 4, and where I see a C, I am now going to replace or substitute 2 plus 5D into the equation. Everything else stays the same, only that is being replaced. It's a direct replacement or substitution in. Again, you guys have been rocking it out. We're going to distribute here, so you get 4 plus 10D plus D is equal to 4. Now we go into combining like terms, and you get 4 plus 11D, because remember that D that has no coefficient, has the coefficient of 1, is equal to 4. Next step, subtract 4 from both sides, because we want to eliminate and get the variable all by itself. Okay, so 11D equals 0. Still do that next step to make sure you're good with this. We're going to divide both sides by 11, so D equals 0. It's okay for D to equal 0, because remember, that's just another number there. Well, again, I'm not done. So now I have my choice. I can plug in this value of D into this equation. I can plug in my value of D to this equation, or I could plug in my value of D into this equation to solve for C. All three of these will work. You will get the same numeric answer for C no matter which one you plug it into. I'm going to choose this one just because it's already solved for C. So when I do so, I get C equals 2 plus 5 times 0. So C equals 2 plus 0, thus C equals 2. Now, here's a great example. They don't give you X and Y. They gave you C and D. Put it in numeric, or yes, alphabetical order. So C goes before D, so you would write it as 2 comma 0. All right, so here's another problem that's similar to the one we previously did. So again, we're using substitution to solve the systems of equations, and neither one of these equations is already set equal to a variable, because it doesn't matter which one. You guys have worked with both of them. But again, go back and look at the ones who have a coefficient of 1, okay? Any three of those are really going to be super easy to solve for. I don't care. Again, dealer's pick. What will your choice be? I might go ahead and solve the second equation there. I'm going to go and I'm going to solve this. Solve for x, okay? Because again, I like positives. So to solve for x, I'm just going to add y to both sides. And then I would be left with an x equals 8 plus y. That was simple, okay? So again, since I used this equation to get this information, I've got to plug it back up into the original. So the original equation tells me, and I'll rewrite it here just so we have that, x plus 3y is equal to 12. Well, now my new x, here's what x equals 8 plus y. So I'm going to say, and I'll put it in parentheses just so you can see that, 8 plus y plus 3y equals 12, okay? So 8 plus y plus 3y is equal to 12. Again, combine like terms. 8 plus 4y is equal to 12. Subtract the 8 from the both sides. 4y is equal to 4. Divide both sides by 4, so y equals 1. Again, I'm not done. I've got to go back up here and plug it into either this equation, or this equation. It doesn't matter which one you choose. I'm going to go ahead and this because it is solved for x. So if I know that x is equal to 8 plus y, I know that x is equal to 8 plus 1, so x is 9. So again, for my final answer, I'm going to say 9, comma 1, and make sure I have those parentheses because it's representing an ordered pair. Great job. Now we did it.